let's start off with two-dimensional analytical geometry. And first thing we have to understand is what does that mean? Basically, using algebra doing geometry is analytical geometry. And since we are restricting our field of study to a two-dimensional plane, that is why it is called two-dimensional analytical geometry. And in geometry, the first thing that comes up is a point. So what's a point? The position of a point in a plane is determined by an ordered pair of real numbers. Now, remember when we were graphing, we had this two perpendicular lines which are marked with lines, vertical and horizontal lines. Now imagine you are standing here and you are interested in reaching here. Now if there are no restrictions to your movements except that you can go either north-south or east-west. So how would you go? So you could go like this, or 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 like this, or like this. See, the point is, going from here to here, there are many ways in which you can go based on these restrictions. But ultimately what it boils down to is that you are going to go so many steps in this direction and so many steps in this direction. That's what it boils down to. Okay. And we also know that this is called the x-axis and this is called the y-axis. So what it boils down to is so many steps in x direction and so many steps in y direction. Remember, this is one number line and this is another number line. And number lines can be used to represent all the real numbers. So, which means just by putting these two lines, we can represent any point on a plane. So, for example, a point P can be represented by how many steps in x direction and how many steps in the y direction. So just these two numbers can specify to us where exactly a particular point is. Of course, we need to have a starting point of some kind. Since the real numbers we are talking of, there will be some positive numbers and there will be negative numbers. So which means there has to be a zero somewhere, and we say that the junction of this x and y axis is the origin. Now this side we mark it as x and this side we mark it as x prime, y, y prime. So now we can say O is the origin, x prime O x is called the x-axis, y prime O y is the y-axis, and x and y belong to real numbers. X and y are called the coordinates of the point. X is called the abscissa, y is called the ordinate. Now again, if we look at this, we end up with four quadrants. First quadrant, second quadrant, third quadrant and fourth quadrant. So these are the quadrants. Now in the first quadrant, point can be specified using x comma y, because here x positives and y are positive real numbers. In the second quadrant, what happens? This becomes negative. X becomes negative. So p minus x comma y. Y remains positive. In the third quadrant, x is negative and y also becomes negative. So minus x minus y. And in the fourth quadrant, here what happens? X is positive and y is negative. So x comma minus y. So if a point is there here, both its coordinates would be positive. Here it would be minus x and y. Okay, now coming back to our previous diagram. Okay, so we had 2 points. This, let's say this is P1. This will have its coordinates, and P2, this will have its own coordinates. Yes. Now, if the point we are trying to figure out where it is from origin, then how many steps in the x direction and how many steps in the y direction. So x comma y. Fairly straightforward once you understand this concept of coordinates. Now, what's the distance of a point? When we say, let's say we have a point P, we want to know what's the distance from origin. So we know how many steps to go in x direction, we know how many steps to go in the y direction. Now we want to figure out the distance from O to P. Now, as you can see, what we have done is from P we have dropped a perpendicular. Yes, so we know that this is 90 degree, which means we can use Pythagoras theorem. Now the coordinates of this point are x1, y1, let's say, or since there are no other points involved, we can just say x comma y. So that means this distance is x and this distance is y. So by Pythagoras theorem, what do we have? We have OP is equal to x square plus y square under root. Quite straightforward. But suppose we want to know the distance of a point from another point which is not on the origin. So we want to know this distance, right? So let's say this is P, or now that we have 2 points, let's say A and B. So let's say we have A, x1, y1, and B is x2, y2. So we drop a perpendicular here, we drop a perpendicular here. Similarly, we drop a perpendicular here and we drop a perpendicular here. So now the distance from here to here is how much? B is x2, y2. So this is x2. The distance from here to here is x1. Similarly, the distance from here to here is y1 and the distance from here to here is y2. One way is we just convert this into a triangle. We take a parallel line to x-axis and a parallel line to y-axis on this side. This would be what? This would be x2 minus x1. Then what about this? This would be y2 minus y1. So distance along x-axis is x2 minus x1. distance along y-axis is equal to y2 minus y1. Again, this is also perpendicular. So, which means again we can apply Pythagoras theorem. So, we can say AB square is equal to, let's say this is C. We can say AC square plus BC square. Now, AC is what? AC is x2 minus x1 square plus BC is what? BC is y2 minus y1 square. And we can say AB is equal to square root of this. Now, how do we check whether it is correct or not? One way is to say, okay, let's say A is equal to 0, 0, right? So then what happens to AB? AB would become x2 minus 0 square plus y2 minus 0 square, which is equal to x2 square plus y2 square. Yes, and perfectly right. Okay. Now, this is one case. Now, let's say there are 2 points with same abscissa. That means x value is same. That means something like this. Here, let's say A is x comma y 1 and B is x comma y 2. So AB would be square root of x2 minus x1. So here in both the cases it is x. So x minus x square plus y2 minus y1 square, which means 0 square. So 0 y2 minus y1 square, which means y2 minus y1. But remember, it is possible that if we just use this y2 minus y1, we might end up with a negative number, and distances cannot be negative, right? So, which means the magnitude of y2 minus y1 would be equal to AB, that distance. Okay, so which means similarly, if we have 2 points such that their y values are same. So here say x1 comma y, x2 comma y. So again AB is equal to x2 minus x1 square plus y minus y square. So which means AB is equal to x2 minus x1 square plus 0. So AB is equal to x2 minus x1. Square cancels the square root. And since distances can't be negative, magnitude of x2 minus x1. So that is a point in a 2D plane or just plane, and how to evaluate the distance of the point from origin and from another point. That's it for now. Bye.